know. I just know that things fall in a vacuum at 9.81 meters squared
Dude,
on average.
Yeah.
Oh, we
That's
already told
fantastic.
you about that, and then you agreed. Well, that's an average. They do not fall at the same rate. It's an average.
Because we can't create a perfect vacuum, but assuming we can, then yeah.
Oh, there you
would
go.
Be...
So you can't measure it then. There you go. Wah, 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 wah.
Hold on, buddy. Hold on. What about objects in the same vacuum?
Yeah, exactly. Objects in the same vacuum will fall at different rates because of you can't create a perfect vacuum, meaning there are air particles in there. There are some air particles in there.
He's just going to say it's not a perfect vacuum. So, wah, wah, wah.
So one little air particle hits one of the objects and makes it fall a little slower. Is that what you're trying to say?
Not only that, one of those objects always attracts air particles towards it to make it slow down more than the others.
Okay, so the problem is in my example that I'm talking about, they dropped the vacuum chamber itself with the elements, objects separated by elements. So, for example, one object made of totally copper, one object made of lead, one object made of iron.
Yeah,
they
but
put them in a vacuum
peer
chamber.
Reviews of that experiment that you showed. That's like the only one, and it's
Let me explain it to you, friend. You know what happened? They blackballed him. They stopped letting him use the facility because he did a test that flew in the face of religious claims. Straight up cult behavior, brother. But yes, when a mainstream gets a counter result and then rather than repeatedly test it, they blackball the guy who got the result. I tend to believe what he did there because that's called religious zeal that they're treating him with. So why are they so scared of his results?
What was his name? Let me search him up.
His name? I don't remember off the top of my head. But he has a website and he explains everything. He also has his videos. See, the best part about science, brother, is you can reproduce it. You don't need peer review. You don't need a bunch of schmucks who believe the Earth is a globe to tell you whether you're right or wrong. You just need to repeat the test.
Yeah. So, what?
So let me be clear, friend. You have no test. You have no test that demonstrates things falling at the same rate. None. Zip, zilch. You have none. You could not give me one if your life depended on it within the next 20 minutes, dude.
Let me get back to you on that. I'm gonna find out how I can make a fucking vacuum chamber.
Okay, sure.
Just to be clear, before we go on,
I have a vacuum chamber. I have one. What do you want to know about it? I have a vacuum chamber.
Yeah, perfect. So
you guys have awakened something in me, and I'm gonna fucking buy a vacuum chamber.
This is easy, dude. Here's what's easy about this, brother. Homie just told you he has a chamber. He could vacuum it for you. You could then carry it up to a high building. And see, when they did this test, they put the camera attached to the chamber. Now, they had a rig which made the chamber stay straight up and down, so you may have to work on that. But you could do this, brother. You could do it.
I don't care if there's a variance in my... I just know that if it falls at, like... Basically, it falls at about the same rate, okay?
Now it's about the same rate again. Now it's kind of the same thing.
But you keep.
I thought it was about mass. Hey, why would things fall at a different rate if they're different elements? I thought it was about mass. That doesn't make any sense.
I don't subscribe to that experiment, as I've said before. So you can bring it up, but I'm not gonna.
So you just deny that it happened then?
I'm saying there's a probability that it isn't correct because it's not peer reviewed. That's all I'm saying. There's a higher probability.
Hey, listen, dude, find me the peer-reviewed paper that proves that peer review is an arbiter of whether something is better or not. And then after you don't find that paper, go read the paper called The Peer Review Crisis, and then get back to us.
Okay, then if you don't, okay, so we just need this guy to repeat his experiment.
Let me ask you this question, dude. Why is peer review add to the credibility of anything? Do you know why?
Because humans are fallible and we work better as a team.
No, I don't care about that. You're just telling me a truism. Why is the peer review process make it more credible? What about peer review makes it more credible?
I just told you.
No, you didn't, dude.
Because humans are biased, and bias.
Right? Exactly. So girls cheat on guys. Therefore, if my friend tells me whether she's cheating, then it doesn't matter. Good grief, dude. We already know people do bad things, dude. What specifically about peer review eliminates the bad things that people do that makes it more credible?
I just told you. It
No,
doesn't.
you
It's not.
didn't. All as you did was just repeat multiple times the flaw you're attempting to correct, but you didn't tell me the method that's going to correct that flaw.
We're all fallible, so we try our best to curb it.
Hey,
But
thanks for
I'm not
repeating
gonna
it
say.
again, dude. Thanks for repeating it for a fourth time, dude.
So do you
So
have an
now that we
answer?
all know the problem, now that we all know the problem and you've repeated it 4 times, what's the solution, dude?
I told you my solution, but you're not happy with it. So
No,
what
you
is
said
your
peer
solution?
review. Peer review is just a title of a process. What about that process makes it more credible?
Because there's more people involved, and so bias is
Oh,
less
so
of a
more
factor.
people. So check this out. More flawed people involved equals a better result. How does that work?
Sounds like a
But how,
conspiracy.
but how does it work your way? If we're flawed, it
That
doesn't.
sounds like it should be worse. That sounds like if you add the amount of flawed people, it'd be worse. So actually, sir, what happens is you have a method or a process that you follow. It's
Yes.
not just a bunch of people get together and just spontaneously agree or disagree. So what about the process? What specifically about the process makes it more credible? The correct answer is you have no freaking clue what you're talking about. That's the correct answer, friend.
If it's repeatable across, like, if it's repeatable by many people, it's better than.
Yes, okay, I agree with you. I agree with you that repetition is better for making it more credible. But let's be clear, friend. Peer review is not repeating the experiment. In case you didn't know that.
Well, ideally it is, right?
So listen,
Ideally,
friend. We all know that you just got exposed. That you have no idea what you're talking about at all. None. Zilch. So why don't you go peer review your answer and come back and give us a better answer?
I was just exposed. Damn.
Yes.
That's what you're talking about, bro. You said peer review is because humans are fallible, so we're going to get more humans.
No. I said that humans are fallible. So if you have more people, checking
you're
the
going
work.
to get more humans.
Yeah, you get more fallible to verify the fallible. We get it.
But people are fallible at different degrees, right?
Right. Yeah.
Right.
So look,
fallible.
if you get an electrician, right, and you say, "No, I don't want to hire an electrician. I'm just going to hire Bob," and then Bob doesn't know how to do electrical, and so to make it better, you hire
Get a
5
different Bob.
people that don't know. Listen, you hire 5 people that don't know how to do electrical, then maybe it'll come out right.
But that's the point. You look at the credentials of these people, right?
Yeah, that's the point, dude. The point is you don't know what you're talking about, dude.
Are you appealing to authority? I don't understand.
Shit,
No,
bro.
you are. You are.
I'm not. I'm not.
Dude, I'm glad 50 people have to do it now. 50 scientists now have to go do it somewhere. You're appealing to authority.
You're a moron. Hey, and then he said he gave him the perfect example to understand what we were talking about. He said, "Oh well, we're gonna get this bad electrician named Bob, and then we're going to get 50 more bad electricians because Bob is not good enough." And he gonna say, "Yeah, that's right. That's how it's gonna go." Like, dude, you're not
So when the electrical inspector comes and fails you, you'd be like, "Dude, why did I fail? I had 5 bad electricians working on it."
It depends on the experiment, right? Some experiments can be done by the layman. Others, I mean, not so much, because if you don't understand like math,
So
it's
if
going to
I
be
have a
harder.
vacuum chamber, am I allowed to do it?
Sure. Yeah.
So why if my next door neighbor doesn't have a vacuum chamber, is he allowed to do it?
Okay. Oh, hey, Radwin, check this out. I think we all got to pause for a minute and just recognize something. This homie just said that if you reproduce it and scrutinize it through the reproduction process, right? That would be the best thing to do. Okay, great. So then ask yourself this question, Fred. Why did the people at the Bremen Drop Tower facility, why did they not work on his test more? Why did they stop it and tell him he could no longer use the facility? Why?
I don't know who this guy is.
Doesn't matter. His name could be Frankenstein. I'm just telling you what happened.
I mean, it kind of matters.
His last name was Hitler. Does it matter?
I mean, yeah, it matters because I want to learn about this guy. I want to know his story.
Why? What are you
wanna
going
know
to
what
learn about
happened.
him? What are you going to learn in his backstory that's going to help you make him drop things in a tower?
I just want to because you guys are claiming that he got blackballed, right?
You should be focused on the experiment, not him.
Yeah, so I'm gonna
That's
buy
kind
a
of
vacuum chamber. I don't know.
people than focusing on the actual thing you're trying to prove.
Yeah, I'm gonna buy a vacuum
It's
chamber.
not a website. It tells us the whole story, man. I can't give it to you now because I'm trying not to die in the snowy road.
What are you going to do with the vacuum chamber when you get one?
I'm gonna drop shit in it and I'm gonna film it in slow motion. Number one, to see that things actually fall in a vacuum at the same rate. That's number one.
Interesting. So you have no idea what you're getting yourself into. That's funny shit.
Yeah, I think it would be more important. I would think it would be more important to have a step-by-step process that any person, even a layman, could reproduce the process, right?
All right.
I think that's
I'll
more
write
important than a peer review of a bunch of people with degrees saying, "Oh yeah, that's right. Oh yeah,
No,
that's
you
right."
know what?
Never did the experiment whatsoever.
You're missing the point. You're missing the point. To peer review, like to submit a white paper, you have to you have to describe what it is you're trying to prove and how you did it.
Yeah, and then the person that peer reviews it, they say, "Oh, that sounds about right. I approve." That's what they do, dude.
I mean, yeah, sure. Some of them, I'm not denying that some of them do, but you can't
All
deny
of
that some of them
them.
don't,
Yeah,
right?
well,
All
dude,
of them.
all of our flat Earth papers have been peer reviewed, and we said, yeah, we agree with them. So now, what's wrong with them?
Exactly.
Okay. So you've done the experiments.
No, we
You
agreed
went
with
to the Bremen
them.
Drop Tower.
No, we peer reviewed it.
Yeah, we peer reviewed it and agreed with them because I own a vacuum chamber. I don't need to go do it because I already know how they work.
I just told you that that's not what a valid peer review is.
That's what a peer review is, man.
That's
They
what
read
you're
the paper.
saying.
They said, "Oh, that sounds about right," and then
Hey,
they agree with it.
Before I forget, when you go get your vacuum chamber, the first thing I want you to do with it is take like a shot glass, maybe a half a shot glass so it doesn't take you all day, full of water, and put that down in the bottom of your vacuum chamber and close it all up, and then pull the vacuum on it and see how long it takes for your vacuum chamber to dry out. Time it.
Sure, yeah. Once I get this fucking vacuum chamber, we can do whatever we want.
Oh, beautiful. So you haven't figured out what that means yet. Good.
I don't know. You're saying it's gonna freeze? What are you trying to say? Repeat it?
I said put the water in your vacuum chamber, pull the vacuum, and time how long to hit start, hit a stopwatch, and time how long it's going to take till your vacuum chamber is completely dry.
Okay. I let me think about that. So water in the vacuum chamber. What's gonna happen to the water? I don't know.
Well, since we're talking about this thing that you think is an experiment, let's talk about it for a second. Let's say you get yourself a vacuum. You got yourself a vacuum chamber, and you drop shit in it. Okay, great. What is that going to be proving? I'm just curious.
I just want to see if it falls at about the same rates, because I don't want to just believe what Google tells me, right? And since you don't believe the video I posted.
No, that's not what we're saying here. I'm just curious. This is not an experiment yet. You just made an observation. You observe. Let's even say that they all fall at the same rate, right? Let's say that for the moment. They all fall at 9.8 meters per second per second.
Mhm.
What about it?
That this phenomenon exists, and we don't know why.
Okay, so we have a
Does that prove the Earth is
phenomenon.
a ball?
Huh?
Yeah. What does it have
Does
to
that
do with
prove the Earth
anything?
is a ball?
But that's not what I'm saying. I'm just asking, like, this is a problem in your guys' like worldview or in your model, in
not.
your framework. Yeah, it kind of is.
No, it's not.
Really? No. We only bring this up to show you that not everything falls at 9.8 meters per second per second. We hope that people will kind of acknowledge that this is not a phenomena that's observed. This is an average. But even if that does occur, what is it supposed to prove?
That
It
things fall at
proves
9.8 meters per second per second.
yes.
Right, okay,
Yeah.
that's great. Let him answer. You said that's a problem for flat Earth. What's the problem?
Because you guys don't believe in gravity, and you can't give a
So-
better
so-
model. You
Oh
can't
my
give a
goodness,
better.
dude.
You can't give a better answer for
Okay,
for
when
what it
somebody
is.
says they don't, quote unquote believe in gravity, what do you think they mean when they say that?
I'm guessing you don't believe in the warping of space time, right?
So yeah,
You
no,
don't believe the
space-time
attraction
warping
of
shit
masses.
happens on a flat dude. Space-time warping shit happens on a flat Earth. That's why the Earth is flat, because of warping space-time. How do you like that?
Right,
I don't
but
really like it.
Relativity
let's
works on a
parse
flat
it
Earth.
out. Yeah, that's great. Let's parse it out, friend. So, what you noticed that you had to separate the two. You had to separate the phenomenon that we all observe from the cause. Okay, everybody observes things falling or things rising depending on their relative density to the medium that they're in. Okay, things fall down,
Mhm.
things rise up. Everyone experiences that. Nobody's denying that.
I'm not denying
Nobody in
that.
their right mind would ever deny that except Globers. Let me explain.
What?
Globers actually do deny that. Yeah, I said let me explain. So let me explain. I'll explain. See, all of us experience things fall down and things rise up. A Glober comes along and says, no, that's not falling down. It's actually falling at a diagonal to another radial towards the center of a giant ball that I can't see. So we, the flat earthers, are actually congruent with up and down. You think everything is in and out to a giant ball. So you're the one who actually denies what we experience, not us. Go ahead.
No, let's say I don't believe on the globe, right? This is still a problem because this phenomenon, it doesn't follow in your framework because your framework relies
How?
on buoyancy and
What?
what's the other one? And
No,
down, I
dude,
guess,
dude.
right?
Hey, listen. Yeah,
Buoyancy
fair
and
enough, dude.
difference
But
in density.
that's just what we observe, dude. That's just describing what we observe.
Yeah.
Right. So again, what we have is everybody agrees on the phenomenon, except Glovers who lie to themselves and say they're observing something falling to the center of a giant ball, which they never see with their own eyes. So they've never seen that, they've never experienced that, and they're lying to themselves. Versus flat earthers who see things go up and down. So who's right? Who's more right?
So essentially, you're trying to say even if this were the truth, yeah, I mean that's fair, right? But it does show that there's a hole in your understanding, right?
Oh, it doesn't at all.
How doesn't it? Even if you don't believe
Now,
in the globe,
listen.
even if you don't believe in the globe,
I
at
could
least
create any mathematical matrix I want to explain a phenomenon.
no, like listen,
Okay.
even if you don't believe in the globe, like there are tons of simulations that show that if this phenomenon is true, that it does. Have you played any like galaxy game?
Who cares? Who cares, dude?
Well, you should because math describes our world.
No, it doesn't, dude. Let me explain. It's very simple. I could disprove this so easy. So if I add $1 million and $1 million, that makes $2 million. But my bank account has a lot less than that in it. So I could make a statement: 1 million plus 1 million equals 2 million. Therefore, I have $2 million in my bank account. But the material fact that it's in my account isn't correct. So just because you have accurate mathematics doesn't mean you have reality, my friend. I'm sorry to break it to you.
I mean, yeah, you can argue that, but it's better to have
No,
coherent
it's
math
not
than
about
not.
arguing it, dude. That is a fact. Just because you have accurate mathematics does not mean that that is the case, that it corresponds with
I
reality.
agree with
It
you.
doesn't mean that you can create realities out of nothing. So, for example, I went to the bank to get a house, and they said you need $50,000 down payment. I said, well, I have $25,000, but I also have $25,000 of dark money. Now I have $50,000, and my math checks out. They said, well, dark money, that's retarded. I said, yeah, just like dark matter. You just make it up with math, brother.
I mean, sure, but if you plug in the numbers right based on what you observe, then your simulation is going to be close to what you observe. That's all I'm saying.
What? Okay, that's great and all. Let's say you have a simulation of a planet forming due to gravitational accretion. Let's say that's true, which it isn't. When they do a simulation trying to get a planet through gravitational accretion, they don't get a planet. In fact, they have to add extra math. They have to add extra numbers and fudge the numbers to get it to work. So nice try. Too bad. So sad. So they can't even model this dude. It's a joke. Not only is it not modeled, it's not witnessed. Nobody's ever witnessed it happen in the history of mankind.
I think I think there's a lot that isn't out there yet, right? I mean, because the government.
Oh, really? So it's not out yet. So that means nobody has the
No.
evidence.
That's not
So
what
you're
I'm
just
saying.
admitting there's no evidence for it.
I don't know if there's evidence for it because I don't know what you're talking about. But I'm just saying, like,
What you're
we
talking
know.
about is planets forming from gravitational accretion. So gravity causing planets to form. That's what I'm talking about. Nobody's witnessed it, and you can't model it.
Gravitational excretion. Like it's
Oh my
excreting
goodness.
gravity. What are you saying?
No, it's called oh my dude. Do you want me to use dumber language? I thought you were like
That
a
would help.
peer-reviewed journal reader.
No, I'm not. So yeah,
Yeah,
that would
that's what
help.
we all know.
Why are you asking for
know.
peer-reviewed shit and asking for all this shit if you're not into it?
I know, bro.
What? How does like reading a peer review paper make me a scholar or not?
You don't even know what you're going to be reading.
Yeah, but it's a starting point.
Yeah, but how about you start with just going and looking and see if water is flat?
Yeah, so to Radwin's point there, my friend, what he's trying to explain to you is that you don't possess the acumen, the ability, the skill, or the knowledge to be able to judge whether the critiques within a peer-reviewed paper are valid or not. So you wouldn't know what you were reading. It'd be Greek and Spanish to you, and you just trust whatever the doctor with a name doctor on the end of his name said. That's what he's trying to tell you, friend.
No, yeah, I might not have the acumen to do it, but I can at least like try to reproduce it if I can read, so if the instructions
Here,
are
check
clear
this
enough.
out. When you go and buy that vacuum chamber and you put the water in it, you're going to prove that gravity is not holding water down in the shot glass, that it's actually air pressure. And when you remove the air pressure from around the water, it turns into a gas and also leaves your vacuum chamber. So that debunks your globe with air around it in outer space vacuum. So good luck when you buy that.
Well, not if you have gravity, right? That's the whole point.
You do have gravity. It's right underneath the vacuum chamber, and it didn't hold the water down. Bum, 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 bum.
I'll look into that. Yeah.
Does gravity make the Earth a ball?
I think
Or can you have gravity exist with any surface?
I think they're interlocked, right? When this is according to, like, I don't know, like, this is what I saw. When the Earth formed, it was like very liquidy, and then it started to converge into this center of mass.
Whoa, bro. This is 24/7 Flat Earth Discord, not a religious channel. Now, there is a religious channel in the server. You can go talk about your creation story from your religion all you want, okay?
Oh no, I meant like when like an asteroid or whatever it was that hit our Earth. That
Prove it.
Yeah, hey,
created
bro,
our
I
moon.
just said stop talking about religion, dude. We don't want to hear your creation story. Otherwise, we just start talking
That's a good
about the
one.
Christian creation story, okay?
All right. Oh, wait, hold on. You said unless it's about the Christian.
No, I said if
Wait,
you're going to talk about your creation story, I'm going to talk about mine, okay?
so you're a
Because you're
Christian.
just talking about things that allegedly happened in the past that nobody's witnessed and nobody can reproduce, and you have to take it on faith. It's part of your religious creation mythos, okay? Sorry to break it to you. It's not science.
That's fair, but it is a valid simulation that gives an
No.
answer.
That's a valid simulation once of what my life would be like if I was married to Scarlett Johansson. Therefore, I am married to her. Wow, see how stupid that is?
A valid simulation of what? You don't have anything to simulate yet.
Exactly. You don't have a natural observed phenomenon of something happening. Like you're basically just doing science fiction. Like you might as well be
You don't
making
have
the
anything.
Starship Enterprise.
You don't have anything to compare your simulation to make sure it's correct.
True.
Yeah, I'm not saying it's correct.
So
I'm saying
when we simulate, well, I don't anymore. Our team is so big now. It's funny. I don't actually have to do anything now. It's just weird. It's weird feeling at work. Anyway,
you probably
so
should.
when we simulate a machine, we clone a machine or we make its digital twin, it's called, and we simulate that thing making a part. It actually, when we make the part, will make the exact same thing. You know why? Because we programmed our digital twin to be exactly the same with measurements and numbers and everything else. So we had to model it to be exactly the same. And it works because it's exactly the same. But you don't have anything to model.
So in other words, you have direct validated process, right? The end result is the validation.
Yeah, but you can't do that in math, right? That's how equations work. You can start with variables and an answer.
You can have all the math you want, but when your robot goes through a machine door and it's $150,000 to repair it, you're going to be like, "Oh, that was the math's fault."
Hey, Radwin, you're not getting it, Radwin. I'm sorry, but you're about to be so rich. What you're going to do is you're going to walk into your boss's room and you say, listen, bro, we don't even need the robots. All we need to do is do the math, and then the result will come.
No, we just have to make the digital twin and just run that.
Yeah, exactly.
Because we already proved if you make a digital twin of the actual machine, and then you start making parts on the digital twin, the machine will also be able to make those parts. So just throw out the machine and we'll just put digital twins everywhere and we'll make digital parts.
Yeah, so somebody orders like this somebody orders like this pneumatic actuator cogwheel, and it's like 57 pounds normally. Then they get this box in the mail and it's super light. They're like, what's this? And they take it out. It's a USB stick. Just plug this in.
No, it's just it's a thin, one of those really thin manila envelopes, padded though. And then you pull out the card, and on the card it says what it is.
Yeah.
So you work with CAD, huh?
Yeah, a long time ago. I don't have to do that anymore. AutoCAD, SolidWorks. I have SolidWorks installed on this and AutoCAD installed on this computer.
Now, don't get me wrong. We're busting your chops, bro.
Huh?
We're busting your chops. We're busting your chops, but we're doing it in good fun because what you're being told here is that a lot of the things you think you know. Yeah, I know. I could tell. But I'm just saying a lot of things you think you know that you were told are correct. They're just based on fantasy. There's no real world application or proof.
I'm not saying to just believe it, right? I'm just saying that there's a reason that it's the consensus, and I don't know. It points to. I'm not saying it points to the truth, but points to a better likelihood of the truth because more eyes have looked at it. Just like you guys here, there's an echo chamber
that's
here.
great. That's great. I would agree with you. So are you a Christian?
Nope.
Or a Hindu or Muslim? One of those? Are you one of those religions?
No, I'm just agnostic.
Why not? Why aren't you one of those? Because there's billions of people in those religions, dude. So how could they all be wrong? So many people, dude. They agree on the same thing. How could they be wrong? And if you add Christians and Muslims together because they allegedly have the same monotheistic root, now you have the majority of people on the earth believe the same religion. Why don't you?
So that's a good question, and yeah, and let me think about that. It's probably it probably has to do with the human condition. I'm gonna give you like an answer here. Like I'm gonna think about this. It probably has to do with the human condition. For we want meaning, and being agnostic does not give you meaning. Humans.
So you
crave
don't
meaning.
want me. So you don't want meaning. Then you came in here because you don't want meaning. You're agnostic.
Am I gonna get shat on for being agnostic?
That's
No.
awesome, dude. You came in here because you don't want to know anything. I love it. You're just punching yourself in the face over and over again. It's wonderful.
It's the way I cope. We all cope though.
No, dude, people don't punch themselves in the face live on the air over and over.
Hi, Mom.
We're clipping it and sending it to her. It's gonna play on her car when she starts it.
Oh, she's gonna be so. I don't know. Might be disappointed.
So is your stance that because there is a large amount of people adopting an idea that because of that there must be some kind of merit to the claim?
It depends. It depends. If you're claiming something that no one has ever saw or has ever seen, then it's less likely. And if it has to do with like religion, then it's I'm not gonna put the same weight on it. But if you're talking about like physical
brother,
things, like
let me help you
empirical
out.
things. Mm-hmm.
I'm glad what you just said, so let me help you out, dude. How many people in the history of mankind have seen the earth as a globe with their own eyes? Do you think?
Probably not a lot.
Less than 30. Okay, less than 30 people claim to have seen the globe with their own eyes. How many people claim to have seen Jesus Christ with their own eyes? Hundreds upon hundreds upon hundreds upon hundreds upon hundreds. Same with Bigfoot, by the way. There's more people that saw Bigfoot with their own eyes than saw the earth as a globe, brother.
See, the thing about that is all we know is we found some books that were that we dug out from the ground. And as far as I'm concerned, that's just proof that the book was written, not that any of it's true.
What?
The only thing that
we're not trying to divert away to religious texts at this point, but what would be, numerically, so you admitted this. So very few people, in fact, fewer people have seen the earth as a globe, allegedly, than people that have seen Bigfoot or Jesus Christ in the flesh. So according to the consensus, your standard, by the way, what is the likelihood that the earth is a globe?
based on the sheer number of countries that, okay, maybe not the sheer number.
People. You said people.
Yeah, but politics matters, right? And
no, it doesn't. We're talking about seeing the earth as a globe with your own eyes. We're not going to divert from that. That was your standard.
Wait, okay.
What is more likely, Bigfoot or the globe?
Do we have footage of Bigfoot?
Holy cow, it doesn't matter. Just by the allegations, right?
I have footage of the Loch Ness Monster.
Do you?
I've got an image of Elvis and Bigfoot riding the Loch Ness Monster.
Holy fuck. Yeah, that's got me.
But we're not going to divert. What is the likelihood, because of the eyewitness, the alleged eyewitness testimony, whatever?
I'm not saying, but you're misrepresenting me. I'm not saying.
You said earlier it's because that there's a reason for this many people, this consensus, which, you know, as far as the Western nations are concerned, most of them, in fact, probably most of the world, is under the impression that they live on a sphere. You think that there's a reason for that, right?
Yes, there isn't a consensus on Bigfoot. Yeah, there is, that he doesn't exist.
Fine. We're talking about the globe now. So who has seen the globe in its totality less than 30?
Mm-hmm.
So what is more likely, Bigfoot or the globe?
That's just, you're just like strawmanning what I said. That's not what I said.
Okay, so fine, I'm fine. So you don't actually care about the consensus or the reason for the consensus. We should just be sticking to empiricism then, right? I agree. So if there's no curvature to the Earth, gravity is not an independent variable in any experiment. There is no detectable motion measurably with any method that we can find, even according to Einstein, optically, that the Earth is in motion. Then we'll just go empiricism based, right? So everybody's empirical judgment call here is that the Earth is flat, stationary, and enclosed.
You know what, Sasu, what I just realized?
What's that?
It's actually logically possible, statistically, that there are more people who believe in the Abrahamic God than believe in the globe. Because there's 4.5 to 5 billion Abrahamic religion adherents. That's greater than half of the entire world's population. And keep in mind, the whole world's population includes elderly, young people, people in all kinds of third world countries, right?
Yep.
So I could actually make an argument that the Abrahamic God is more believed in than the globe.
I think you might have something there. Yeah.
Yeah, it points to definitely points to something.
So what are you going to do with that? I mean, if you don't have any evidence and the consensus apparently is no good, like that's a straw man or something, right? I misrepresented your position. You don't think consensus has anything to do with it. According to the measurements and what we can actually experience, the globe is a silly proposition.
No, I think I said the consensus does point to something. It points to a higher likelihood of it being the truth because more people have had the opportunity to test it for themselves.
So that doesn't.
Wow.
That's not what consensus means, brother.
No, I know it doesn't mean that. I'm just saying that to have a consensus means that the majority agrees on it. Now, whether or not the majority have tested this individually, I don't know, but it does mean that they now have the knowledge to do it, right? And that means something to me. It may not mean anything to you, but it does to me. It's better than like only.
Is it possible? So is it possible that the consensus, you think it means something? I agree with you. I think it means that most people have heard the same rhetoric and believe the same rhetoric without ever having tested it on their own. In fact, without testing it and even their experience defying what they've been told. That's what I think.
Yeah, but it facilitates this defiance better than if no one has heard of it.
Facilitates. Hold on a second. What facilitates the defiance? Their experience?
No, I'm saying that the more number of people there are that are involved, the higher likelihood that if there were something to defy, that it would happen, right? It's a higher likelihood.
Involved with what? You're going to have to be a little bit more specific. Involved with what?
In whatever we're talking about, and whatever the consensus is.
Well, we're just talking about people. So most people believe a thing. That's what we're talking about. The consensus believes an idea. That means that they've all been given the same idea to believe in. It doesn't have anything to do with the evidence.
Sure, but within this population, there's going to be people who test it for themselves, like I am about to
Who
do
would
with
they
this
be?
vacuum chamber.
Right. Well, who would they be? Because you don't actually know of anybody that's tested this for themselves, other than the people that you're talking to, by the way.
Yeah, but I can say that about anything.
So when you prove that it's air pressure that's holding that water down in the cup, what are you going to say?
Yeah, I'll get back to you on that one. That's a good question. I don't know yet.
Oh, good. Thank you.
So more people believe it. You don't know anybody of this group that believes it has tested it. You don't know their names. You don't know what they did. You hope that they exist. But the people that you are talking to right now have challenged all of the claims made. And we were the people that you're talking to, by the way, at one time were part of that consensus. And we have then now changed our minds because what we have tested has shown that the claim is false.
I mean, I don't know, maybe. I have to test it for myself.
But yes, you will. I mean, that's the ultimate, goal here is for not for you to take our word for it, but for you to go ahead and test it. See what happens with the moisture inside that vacuum chamber. See if you can find any measurable curvature. And between those two things, I mean, the stationary Earth thing is basically a given. But
where did you do your laser test for curvature?
Oh, I didn't do a laser test. I did a long distance observation.
Let me ask you something, Sauce.
Mm-hmm.
Can I ask you a quick question?
Yeah.
So, if you go out and do an observation with a form of measurement, right, over long distances, and you discover that the Earth is flat, what does that mean that gravity is? When you say gravity is something falling at an average rate of 9.8 meters per second squared, if the Earth is no longer a ball, what does that mean gravity is?
I don't know. It means, yeah, I don't know. Because if it doesn't tell me the shape of, or your question is, if I found that the world was flat, what does that say about gravity? Yeah?
Yeah, we still see things in a vacuum falling at an average rate of 9.8 meters per second squared, right? We're not denying that.
Could mean a few things.
What now is in contention is that R value that they like to throw into those math equations.
It could mean a few things. Either the radius of the Earth isn't correct, which I doubt, but
it can't be that. You want to know why?
Why?
Because if that's wrong, the distance to the moon is wrong, the size of the moon is wrong, the distance to the sun is wrong, the size of the sun is wrong, the orbits are wrong. Everything's wrong if the radius value is not what they say it is.
No, I know. That's why that's like not likely.
Satellites are no longer orbiting Earth.
The thing is,
you get what I'm saying?
When I go to the Great Salt Lake this year, I'm going to do the laser test and see it for myself. I'll give it to you. It's sus. I don't know why we don't see a curvature at that distance. But I'm not just gonna trust this guy. I'm gonna go do it. So if I really see this fucking laser from that point to the other point, I don't know, man.
What does that mean about gravity then? What does that mean about gravity?
It doesn't say much about gravity. No, it doesn't say much.
Does it mean that gravity makes the Earth a ball, or does it just mean that things fall down at 9.8?
It means gravity pulls light around the ball. That's why he sees it.
No, I don't think that at this distance it's going to be. I'm not sure.
At what distance does gravity pull light around the ball?
And that's a good question. Let me not just spout bullshit. Maybe it does mean that. But I know that I've seen videos of like horizontal, like they were filming it horizontally and the light seemed straight.
Like
have fun with your vacuum chamber.
I mean, you should be encouraging them that he's going to go do a test.
I said have fun with your vacuum chamber. Like,
that
when
test?
you do, When you do that one, you're gonna figure out you can do all kinds of fun shit with that.
Yeah, I'm excited. I hope when you go out there and you do that laser test over Great Salt Lake, that you come back in here after you prove the Earth is flat.
I will, bro. If okay, like I said, it doesn't prove that the Earth is flat because it's very uncontrolled. It's not a controlled experiment, right? There's like I know we can't say refraction.
Yeah, but you can control it by timing the time where you go make the observation so that the ground and air temperature are the same. That's how you can control it.
How
And
can
that's
I?
usually like right before the sun rises, or it'll be like right after sunset, like within an hour. It means the air will be mixed together so that there won't be like a gradient of temperature, because the gradient of temperature is the problem. So you want
Sure,
the
but I
air like
can't.
well mixed.
I have to, but that's just another point of contention, right? It's gonna be like, oh, how can I be sure? How can I trust the sensors? How can I trust the data? You know,
What are you
how do
talking about?
It's such a vast distance of this
Dude, you need
medium.
the temperatures to be the same. You just do it in the morning or you do it in the evening. That's it. That's all you have to know.
You gotta remember, refraction like is in.
Are you saying that the temperature gradient is only vertical? I don't think that's true.
No, it's not only vertical, but this is the thing. You're shooting a laser through a single medium. Differences in the refractive index are in the 5th decimal place. You understand?
Sure.
Like the difference
No, I get
between say 30 degrees Celsius air and 31 degrees Celsius air is like 0.000024. It's such a minuscule difference.
What's the farthest distance you've tested? Like
30
since
miles.
you're 30 miles, where?
Boston Harbor, Revere Beach. I did one recently, but it ain't in 30 miles. Yeah, so what I did was I got an app. It's called marinetraffic.com. It shows where the ships are. I sat there, I picked out a big ass ship and just watched it for 3.5 hours and tracked it on the tracking app. And the max distance away was 30 miles. And I could see it the entire time.
Wait, so how did you do it? You had two people doing
filmed it with
this?
an iPhone.
No, I know, but like
an iPhone at 30 miles, I could see this shit.
So you went 30 miles away and you placed the laser.
I was on the beach and the ship went 30 miles away from me.
Oh.
There's an app called marinetraffic.com which will tell you the position of a ship.
Right.
And these ships are tracked by marine radar out of a radar station that's in Gloucester.
On a system that they pay for that's very accurate because I looked it up.
Yeah, it's very accurate. Marine radar is accurate to 5 meters maybe.
Yeah, so you don't run into other ships. That's why it's so accurate. So at night you don't run into people. And there you go.
You were exactly sea level.
I was 15 feet above sea level. They got tide markers. So at that distance from that height, the globe prediction is that the ship is 5 feet, blocked by the Earth curve.
Oh, that's a 40-story building.
Yeah, and the tallest ship in the world is like 280 feet tall or something. So it wasn't that. It wasn't just a really tall boat.
Does the sea have to be flat? Do we know that for a fact?
What do you mean? I don't understand. Does the sea have to be
flat?
flat?
Let's say there is some fucking spooky fucking magic, right? Let's say there is some spooky magic that's making it look flat.
You're weird, dude.
I'm just saying.
You're being weird because you think
how do we know
looking flat is the spooky magic, but imagining it's a ball is not the spooky magic.
No.
Yeah, imagining that it's not flat is normal.
That's not what I'm saying. I'm just saying.
Doing.
No, I'm just saying, how do we know? Okay, so basically, yeah, that's just something we can't measure, right? It's just okay.
I'll tell
It
you one
looks
thing.
flat.
One
It
way we
looks
can know.
flat to me.
Okay, have you heard of the Bolivian salt flats?
No.
Okay, the Bolivian salt flats are like a 40,000 square mile salt flat. That's salt, like Great Salt Lake, right? It's bigger than that though. It's the largest salt flat in the world. Unlike Salt Lake, this first of all, it's like white salt, so it fills up with rainwater every once in a while, like 3 to 4 inches, 2 to 3, 4 inches, whatever. And it forms a gigantic mirror. Gigantic. Like the mirror goes all the way to the horizon, so it's called the world's largest mirror. Okay? The reflection of the sky. So the sky and the reflection of the sky in the water are perfectly symmetrical as if it's reflecting off of a flat mirror. Now, if the Earth was curved, that would be a convex mirror, right? And it would be distorted relative to what you're looking at. So if you're looking at the clouds in the sky, the reflection of the clouds would be distorted if they're being reflected off of a curved surface. And Earth is too big that that actually doesn't work for this because of the divergence amplifies the visible curvature. So like if the sun was setting and you were at like 6 feet above the surface of the water, the sun in the reflection of the sun would be 10% smaller than the actual sun that you're looking at. They would be squished. And in fact, if you can do the calculation, if you go up to 75 meters and watch the sunset, you would see the sun set, but you would actually never see the reflection of the sun in the water because of it's beyond that curve, right? The light that would reflect off of it would be on the other side of the horizon, and it would never be able to reflect to your eye. You'd never see it. So you would see a sunset as if it was a mountain, even though you're looking at a perfectly reflecting surface. That's what would happen if it was a ball, but that's not what we see. We see a perfect reflection of the sky that's symmetrical.
Just play devil's advocate with me for 1 second, okay?
Yeah, I hear you,
if
man. Let's forget empirical observations of the natural world and watch TV more. Let's just do that.
What if the Earth is 100 times bigger than what it is?
No, that's
Then
not what I'm
maybe
saying.
yes, but we only got the numbers they told us, right? That's all we can do is test what they said. You can't test every fucking iteration. Every possible freaking imagined Earth. Yeah, did you see what A.I Overlord posted in the chat? Did you see the image there?
Yeah.
Yeah. Okay, that's just one sample image. Remember I was telling you about the sun? That the sun would look 10% smaller at the horizon? Now these calculations, and I actually have a globe earther actually made a simulator. In a simulator, and it's to scale, it's a 2-scale simulator. The simulator also shows that the reflections are not symmetrical. It's a simulator of the globe. It was made by a globe earther, not a flat earther. And I'll post that in the chat. So the thing is, if you had a curved surface, right? If this surface was curving down, then it would be shortened relative to your viewpoint, and everything as you get as like the reflection got close to the horizon would appear compressed. Okay, so everything toward the horizon should get squished and squished and squished and more squished. But I actually have another image which shows the exact opposite of that. It's actually stretched.
Who is the flat earther and who is the round earther?
Joe Mama.
Oh,
You're the flat earther, and the ground earther is the other guy with the beard.
Oh,
yeah, because the guy with the beard is gonna. Yeah, because you're gonna teach him about the globe because he don't know shit.
Oh God, yeah. Here we go again. I've been doing this all day, as a matter of fact, on frickin' X. Okay, come on, globe earthers. debate me so I can do your globe lesson. Fuck, dude, I'm getting sick of that.
Are you from Texas? No.
No,
Because
all my exes are from Texas, but I'm not.
then I really don't.
Yeehaw!
Yeehaw, ride 'em, cowboy.
No, wait. Mass.
Why are you deflecting, though? We were having a conversation with Sauce here, and you're
Oh, yeah,
changing the
sorry.
topic.
Yeah, sorry. Continue.
Thank you.
Oh, I'm done. There's nothing else to say here. I just got to go.
Okay,
test
so Sauce, don't believe a fucking word we're saying. Consider us all a bunch of liars. Consider everybody in here liars, and everybody on TV liars, and on the internet, everybody's liars. And the only truth you can find in knowledge, absolute knowledge, it comes from you. Now do what you said. Go to the salt flats and do the test. Like, we're not afraid of the tests. We want people to do the tests. The only people that are going to stop you from trying to do tests are globe earthers. Isn't that strange?
No one's gonna fucking like. Okay,
They'll
if
tell
the
you why
police-
your test is not good enough. That's what they'll say. That's all they'll do is poo-poo whatever you're doing to tell you whatever you're doing is not good enough. Whatever your result is, if it disproves a globe, you did it wrong.
Yeah, well, we're gonna have to see.
Yep. I mean, there's a flat earther named Dell, and he made a video a long time ago, and it holds true as it did then. He said, how do you prove something to somebody? Another human being. How do you prove it to them? You
Have to
demonstrate
repeat it.
Yes, a practical demonstration of the claims. And if you can't show it by practical demonstration, then you don't know what the fuck you're talking about. I'm paraphrasing what he said. He said it a little worse than that, probably. But
yeah, if you can't make a layman do it, if a layman can't do it with your instructions, then you don't know what you're talking about. Just like indio007.
Yep.
We're actually, Sauce, you're here at a good time because we're actually, I'm actually doing, well, anybody else can jump on the bandwagon. It's called the Year of the Observation. This year, it's cold right now, but we're going to frickin' just explode the internet with all sorts of long distance observations coming from everywhere, every direction. These so-called globe impossible observations, we're just going to flood the internet with them so that people can't keep their head buried in the sand.
They're just gonna say atmospheric refraction or whatever this is, this mirage, whatever, and that's that. And
Yeah,
then
but
we're gonna have to
then they
shift the
have to,
goalposts.
Sauce, but then they have to claim that the entire world's an optical illusion.
And not only that,
you want to go with that? You want that your position to be? I know what reality is. It's an optical illusion. How do you know? Because I know the Earth's the globe. Because someone fixed the ground 2,000 years ago.
All I know is my fucking my eyes are fallible. That's all I know.
no,
your mind
the
is
evidence for the globe,
fallible.
The evidence for the globe is the Earth is flat.
Yeah, that's it. That's the globe evidence that the Earth is flat. No, listen, your eyes are fallible, but so is your mind.
Yeah, my brain fucking, without my brain, my eyes do jack shit.
But your eye, no. There's people in permanent vegetative states that frickin' have sensory responses even though they have no brain frickin' waves, dude. The senses act independently of the mind.
Yeah, but to receive, wait, what?
No, the senses act independently of the mind. We know this because people that have had brain injuries where they have no brain function still have the reflexes of somebody that can see, taste, touch, hear.
Yeah, but are you saying this person is processing said?
He can't tell you what they're experiencing because he has no mind, but they are taking sensory input, meaning their freaking nerve endings are firing, their photoreceptors are firing. There's there's no brain activity that you can really measure, but you can measure electrical impulses on the optical nerve, right? They're still seeing, but they have.
You can make a vegetative person flinch.
Yeah, you can make them cry. And they're legally brain dead.
How do you know this?
Because people have done it.
I worked in the emergency room.
Sick people, dude. What the fuck?
Called a permanently vegetative state. It's like a coma.
Indio, I missed you, man. I missed your warmth.
Yeah, thanks, brother. Go eat a fucking Caesar's pizza. So people who are in the permanently vegetative state can have sensory perceptions. Okay. The senses that you have are more reliable than your mind. Okay. This is like a silly thing that you guys do for, I don't know, whatever reason, that you try to repudiate your senses when that's the only way you even know the external world.
Yeah, but for instance, I can't see in the dark.
Yeah, but
right?
yes, you can. That's why you have rods, dude.
Okay, you're trying to let the perfect be the enemy of the good.
Sure, but but maybe you need to be more precise, right? All I'm saying is at those distances, we know that our eyes can't see that far.
Yeah.
So now,
I've
the
seen
question
30
is,
miles. I don't know about you. I've seen that far.
Just because it looks hazy doesn't mean you can't see it.
Look, can I read you something about a Navy test? Well, I can just
No,
tell
you
you what
can't.
they did. Thanks, Dad. Anyway, fuck, dude.
Go ahead.
So really simple. The Navy did a test, right? So the test was, it's called the Horizon.
Yeah, that's just not true.
Who said that? You might as well just
Caesar
leave
did.
now, because I'm going to figure out who you are. I'm going to kick you out.
Just go look back at the stream. You'll see.
I'll just mute you instead. So really simple, okay? The Navy did a test called the Horizon Early Detection System, right? So what the idea was is for the Navy to make an infrared camera system that would pick up missiles or whatever at the horizon as early as possible. So when they tested the distance that the furthest distance that they could pick up their test missiles, because they took a missile and they put a big thermal freaking light on it, basically a flare that emits a lot of infrared, and then they flew it, basically a cruise missile, and they tried and measured the distance at which they picked up the missile, and tried to correlate the distance of the missile with distance and atmospheric transmission, meaning how hazy the air was, right? They found that the distance had nothing to do with how far away they could pick something up. And the only thing that mattered was how transparent the air was. But according to the globe, distance does matter, because these missiles are only 30 feet off the ground and they're picking them up 20 kilometers away. They should have been behind the curve of the earth. But the only reason they didn't pick some up was because of how opaque the air was. Because they measured that. They measured the transmission window of the air. So this is just another data point. We can't see things because of haze, because of fog, because of all sorts of things that are in the air. It has nothing to do with Earth curve. So now I'm going to look for the smart app.
Hi.
What's up, Rockman?
What's up, G?
What's up, guys? I'm sorry, my English is not really good.
Okay, just listen then. So, one thing I want to add to everything I said, a lot of globe earthers, they have this prejudice, or people, they think of flat Earth that we don't have evidence. We have tons of evidence. More evidence than you can shake a stick at. You can go on our main server discord.gg/flat earth, and you can look through the information channels, long distance observations, laser tests, salt flats, all you name it, radio transmissions, microwave transmissions, infrared transmissions, all impossible on a globe at distances are way impossible. 800-mile radio transmissions to sea level, 870-mile NATO communication, microwave communication system, 10,000-mile radio communication between the UK and Australia, 6,000-mile radio communication between Washington, D.C. and a plane in
but
the
there's
U.S.
satellites.
Secretary of State's plane over the this is before satellites, buddy. Good try.
When was
before
this?
Before satellites existed.
Okay,
They didn't exist yet.
That you know of. The government's not gonna fucking tell you.
I don't think they existed in 1918. Do you think they existed in 1918? At the end of World War One?
No, but there's also other technologies like repeaters.
There was radio was brand new. There was no repeaters. You think there was repeaters between Cornwall, UK, and Australia?
There must have been. If
there must have been.
How far was that distance?
Must there have been?
No. How many repeaters would be needed from those two locations?
How did you float them in the Indian Ocean?
Well, I'm going to retract that statement. I don't know if there must have been, but like, how do you know that it doesn't? Is it just impossible because in the flat or globe Earth, 100%, you know that for a fact.
Well, it's 10,000 miles. So if the globe has a circumference of 25,000 miles, that's half the distance, right? So this is almost like being on the North Pole and talking to the South Pole. There's a big ball in the way. How are you doing that? The radio waves don't go through the ball.
Let me add this to the list. You said...
So Marconi, 1918, and a guy named Arthur Fisk. It was Cornwall, United Kingdom to Sydney, Australia in 1918.
Okay. Australia.
I can post the plaque, dude. Post a picture of the plaque because there's a memorial plaque. And I can post links to it.
Yeah, that would help.
Yeah, it's very interesting because the way they discovered it was an amateur radio operator. He started hearing radio transmissions in German. And he was like, well, we're in Australia. There ain't no Germans here. And they were picking up radio broadcasts from Berlin in Australia. So they're like, oh, I got an idea. Why don't we try to do that on purpose? And they did.
Okay.
That's a geometry of what the radio... I just posted in a chat a diagram of the geometry of what the radio transmission would have been.
They're saying they utilize ionospheric reflection, which is like something in the atmosphere or some shit.
Okay. That's a cool story. There's no evidence for any of that, dude. Do you know that they didn't... That hypothesis didn't even exist when they did the transmission, right? So do you know how that went? That's an ex post facto claim, meaning they did the transmission, said, oh, how's that possible? Earth's the globe. Well, it must have bounced off the freaking ionosphere. We'll just make some shit up on how it worked on a globe. And it couldn't work on a globe like that anyway, because when you have an inner circle and an outer circle, because of the law of reflection, the angle of incidence equals the angle of reflection. The angle that the radio bounces off the outer circle, which would be the ionosphere.
Can we talk about something interesting?
In the inner circle, which would be the Earth. I am talking about something interesting. The transmission would flatten out and it would never get there. Because the angle would keep tipping down, and you probably need like 300 fucking bounces to even bounce that far. And here's the other problem, is that long-range transmission only happens at night. It doesn't happen during the daytime. They did these transmissions during the daytime. During the daytime, skywave ionic spheric scattering only works for 500 to 700 miles. We've gone through all the objections. We've heard it all. Look, we've been doing this for quite a long time, just to tell you, just to be honest with you. We've heard all the objections. Like, that's why I can sit here, I just call and we talk to you, because I know there's literally nothing you could bring up. You could Google forever. We've already heard it all. We've already dealt with it all. We've already refuted it all. There's nothing. And the amazing thing is, every time, and this is like, the longer I'm in this topic, the more I'm convinced the Earth is flat, not less. Because every once in a while, a globe earther will bring something new that we've never heard before. And on the surface, it seems like on the surface, it seems like it proves a globe. But then when you drill down into the details, it's not the case. Every time.
Well, I mean, I think you should adopt a different mindset. I mean, sure, you could be pretty sure about it, but don't fucking like be so sure that you can't.
Don't tell anybody.
No, that's not what I'm saying. It just sounds like nothing I say will change your minds, and that's not.
No, nothing you say will make the Earth bend.
Okay, yes, things you say could change my mind, but the only thing you can say that would change my mind is some proof that is globe exclusive, meaning it would be something that could only indicate the Earth is a globe. And there's only one thing that can do that. Want to know what that is? Measuring the surface to be curving. That's it. That's the only thing that is available. Everything else is theory-laden, fanciful imaginations about how they think the Earth might work if it was a globe. But we can also concoct some freaking bullshit imaginations, just those stories about how that same phenomenon could work on a flat Earth.
There is one way, but you guys are just gonna say like that's impossible to do. But I think it's the most
go to
feasible.
space?
No, it's more feasible than that.
Okay.
You stay in our atmosphere, or like in the air, and you just fly in one direction and see if you land in the same spot.
Okay, how would you do that, dude?
I know but it's more feasible. Maybe going to space is more feasible. I'll take that back. Build a fucking rocket, go to space, film the shit, and yeah.
Yeah, that's it. Look at it. So the thing that you're on, you have access to, you could measure it right when you're there. Instead, you're going to go far away and look at it.
Yeah, that's because
How does that make any sense?
Because like
I hope no one ever hires you to build a house, because you'd be right at the 2x4 and you'd have your tape measure and you'd be like, let me walk across the street and look at it.
Even in math, right? Sometimes we feel that we're at the global maxima, but you could just be in the local maxima. All I'm saying is get a bird's eye view.
You just said that even in math we feel? What are you talking about?
Yeah, can you adjust what I said about you going to the other side of the street to tell how long a board is?
I'm giving you like some perspective. So locally you can see something.
I didn't say see, I said measure. See, this is where you guys get fucked up. You think we're looking at it. We're measuring it, dude.
Settle down, Indio.
I am settled down. You guys conflate calculation and looking at things with measuring what it is. You can know directly what something is by measuring it directly. I can know if you were here and I took a tape measure and measured your height, can anything change that? Any theory, any hypothesis, anybody being far away from you and looking at you, will that change what the reading was on the tape measure? The answer is no. Okay. That's why we say measure it, because it's a definitive proof. Not because we like it, because it's absolute proof.
If I fly you to space and you see
Didn't you just make the argument against your own senses? You literally observe the Earth flat every day and you reject it, but you're saying you should go to space and look at the ball and accept it.
So even if you were in a space,
so you're in a contradiction, bro.
Well, let me just ask you this.
Yeah, you better go. You better go buy that vacuum chamber. You won't be talking about space anymore.
If you were in this, if you did a round, like you went around the Earth one time, you still wouldn't believe it. You would rather believe your calculations locally, like 30 miles.
They're not calculations, they're measurements.
Okay, your measurements, your local measurements, a 30-mile.
Well, does water conform into a sphere because of gravity?
I mean, if you actually see it, if you see that's the case, you wouldn't believe it.
Okay, so most of the surface of the Earth is water, right?
He's saying your standards are like, damn, bro.
Look, it's a logical progression. Most of the surface of the Earth is water. Whatever's water doing, the Earth is doing. So if the water is not curving, then the Earth is not a ball. It's simple logic. All those things are logical necessities of the previous premise. Right? You can't have a 75% flat ball. So if the water's flat, the Earth is flat. It's just really simple. If the water's curved, the Earth is curved. And if we went to space and saw the Earth as a ball, we should be able to come down here and measure it as a ball. It's odd that you guys are like these dual Earth theorists, man, that you guys think there's two Earths. One flat Earth that you're on and another one when you go to space.
And it changes somewhere while you're going high. It's always flat, and then poof, it turns into a ball somewhere.
Yeah, and then there's fucking machines flying around and comets and spacemen and aliens and all this magical shit. Look, you asked me, said I can't change your mind. You could if you had an actual logically sound and valid argument for the Earth being a ball. And since a ball is a claim about its geometry, you need geometric evidence. Okay? Looking at something can tell you about the geometry, but it's not the true geometry because of perspective. Railroad tracks appear to converge in the distance. That's not what they're actually doing. So, because of this, we use tools to directly measure things so that we actually know exactly what they are. Things like tape measures. So, using these instruments, we can tell whether the Earth is a ball or not, or whether it's curving or not, and then infer from that curvature and the theory of gravity, of forming things into balls, that if the Earth's not curving, then it's not a ball. And that theory's crap. It's wrong.
Guys, because they're just gonna say
Sauce. If I told you a hill, where if I place you in a position on Earth, and then I said in that direction, you see that hill over there? You say, yeah, I see that hill over there. That hill is 6 miles away. How do we know that that hill is 6 miles away?
Rangefinder.
Rangefinder. You can walk it out, right?
Mm-hmm.
Like you basically go out and you make a measurement to the hill, right? To verify that it's 6 miles away, right?
Yep.
Right. So what we're doing is we're saying, hey, that object in the water is such and such miles away.
No, I get that. I'm just saying, even if I were to, they're just gonna say, yeah, it's the bending of the light, or it's.
You're gonna have to prove that.
Yeah, that's
we
fine. But there's
we
no
can demonstrate
for that.
We can demonstrate refraction on a flat surface. Can you demonstrate refraction on a curved surface?
Yeah, that's the crux of the problem. If you ask them, Sauce, what's the evidence for globe refraction? What's the actual evidence for it? Want to know what their evidence is? A flat-looking Earth.
I don't know about that.
Well, I mean, what else is it? They say the Earth looks flat. It's got to be refraction. What else is their evidence?
Let me look into that.
How do you know it's a globe?
And it gets even worse. I mean, it gets even worse than that, because what causes this refraction? The gradient, the density gradient, right? Well, what causes the density gradient? Gravity. Well, what else does gravity do? Forms the Earth into a ball. So gravity conspires to make a ball that compresses the air in such a way that when a human being looks at it, it looks flat. It's the fucking stupidest idea in human history.
Bro, there's a lot of things that are stupid, right? Like fucking
Well, this is the pinnacle, because you have to
Platypuses are
believe that
fucking
you're
stupid,
living in
yet
an
they exist.
optical fucking illusion, in that you can't trust your senses, and that nothing is real, basically.
Before I was ever a flat earther, I used to fly. I would fly some more still. Just don't have the funds for it right now. But the 30 or so times that I flew prior to being a flat earther, every time I was in the air, I would say, "Oh my God, look how big the Earth is. It looks flat still. Can't believe how big the Earth is. I can't see curvature." Every single time.
I flew to
You know
Chicago
you've
a
never
couple
seen.
times, man, and the Great Lakes are flat as fuck, bro.
You know you've never seen curvature. You've never seen it, except in a picture, in a book somewhere, or on video on TV or your computer screen.
No, yeah, for sure. I that's your best point, right? That's the best case for flat earthers. 100%.
You know it's flat.
No, there is no best case. It's only flat. That's the only case.
I mean, I don't know. There's like you guys have trouble explaining satellites and
No, I don't.
So
They
you
don't
want us to
exist.
explain the TV
There you
show?
go. Yeah, they don't exist.
You're asking us to explain the TV show, which you said was our best point, that you don't actually know any of that.
how does GPS work?
Not with a globe. It doesn't even use globe math. Did you know that?
Ground positioning work. It finds your position on the ground. It's ground positioning system.
Okay, so GPS doesn't use a globe.
No,
you
but
on
it
your
relies on
phone, look, brother. When you look at your phone, it shows you latitude and longitude, and you go, "Hey, man, it's doing that on a globe." But the actual GPS receiver, the message it gets, it's called a Rhinex message. It comes down in 3 coordinates, not latitude and longitude. The X, Y, Z on a plane. That's what the math that the receiver actually does. This isn't a conspiracy theory. You can type in Rhinex message data, and you can look at the fucking message data yourself. Every receiver does this. And hold on, to get a latitude, longitude, it does a coordinate transformation and converts the coordinates into spherical coordinates. But it's not natively in that.
But why do we need spherical coordinates if it's just if it's flat? We don't.
Because our coordinate system is stars.
Okay, so you're not saying that
this goes back to your other point about traveling in a straight line. Why you can't actually do that is because you need a spatial reference, right? That you see or you can detect.
You can just
from
have
all the
fucking
points
towers.
on your from all the points on your route to know if you're going straight. Because we can't see a mountain from far away because of lots of reasons, mainly because of the air. But because we can't see a mountain from 400 miles away, we use the stars. We use the stars to navigate, and we created an entire coordinate system based upon the stars. They're not based upon a globe ground. You can't even find your latitude and longitude without using the sun and the stars. Longitude is a solar coordinate. Latitude is a celestial equator coordinate, meaning...
Bro, you guys don't even believe in the stars.
What are you talking about?
What are you talking about, dude?
We don't believe in the story of what they say they are. We see stars. Listen, just
How do you guys
because
know a
we
fucking
don't
screen up
believe
there?
the story that they say associated with stars doesn't mean we don't believe in stars or that we think stars are fake. Stars are real. We can see them, but they're not made of fucking big balls of fucking gas in a vacuum burning at 1,000,000 fucking degrees. Okay? That's what they aren't.
What's the medium between us?
And the stars, we don't know.
The absolute medium, it's a variation.
Hey, Saucy, I put in the side chat a GIF.
I mean,
of a
I've heard one
satellite.
hypothesis of liquid helium-4.
That's a pretty cool. That was a pretty cool one too.
Yeah, I mean, it's not like really testable, but it's possible. It's feasible within the paradigm of physics. It could be helium-4.
Hey, Sauce.
Yeah.
I put a video in the side chat of a satellite. Satellites are real, bro.
So that, yeah, exactly. Balloons, right?
Hey, Biden shot it down, bro. It's real.
That's not
Here,
the only one.
I posted one talking to another one and making an alignment with it, keeping it always in view, basically.
And as I just told you, we were doing 10,000-mile radio transmissions in 1918. Satellites were never necessary to exist because there's never been a ball in the way between radio transmissions.
I look up in the sky, man. I can find Regulus. I can find Polaris. I can find, the constellations. I understand those things, right? I can see Jupiter. I can see Mars. I can see Saturn. I can find them, those three personally, with the naked eye. And in certain days when Venus is in the sky, I can find that too when it's on the horizon. That doesn't make the Earth a ball, and that doesn't mean that you know what the planets or the stars are. You can see them in the sky, but what they're made out of, you have no fucking idea.
And the way celestial navigation works is you estimate how long it's going to take you to get to where you want to go. And then you read which star is going to be over that spot at that time. So
I'll give you an example of how you don't
move,
know.
yeah, if you know that Orion's going to be over freaking wherever, Egypt, in 30 fucking days, and it takes you 30 days to hypothetically travel that far, all you have to do is follow fucking Orion, and you're going to end up in Egypt. You know that 30 days later, if the Orion's directly over your head, you're in Egypt. You know how we know that? Because that's the coordinate system we made. That's how we designated all this stuff.
Yeah, I don't know how to.
They say Polaris is 432 light years away. How do they know that?
That's changed so many times, man.
I know. Do you know how far a light year is,
How many
Sauce?
times has that changed?
Yeah.
At least 3 times that I know. No, how far away? How many miles?
I don't know. I can do the calculations real quick.
5.8 trillion miles. I'll save you the math.
Yeah, that's a lot.
Yeah. So imagine 432 times 5.8.
No, I know.
How do
I
they
know.
know that?
I know space is stupid big according to.
How do they know that?
That's a good question. Let me see.
Yeah, so that's the question we ask. They make claims, right? And we ask, how do they know it, right? And we never get an answer, even when we talk to astronomers, astrophysicists, regular physicists, mathematical, like you name it, we've talked to them. And when we ask them how they know what they're saying, I mean, I had a mathematical physicist tell me he can't prove anything exists, and that like he might not have any hands and we all might be brains in a jar. That's where he had to go because he couldn't actually back up that the Earth was a globe. This is a academic man that was teaching physics at university. when pressed to prove the globe, had to say, we can't prove anything. We could all be brains in a jar. The people that I believe you're relying on when you think that the Earth is a globe, these are the people that the average person comes and relies on. They say, what about the scientists? What about the academics? What about these people? They know the Earth is a globe. Well, we've talked to them, and they don't. They don't know anything more than you. They just heard this story in high school and just accepted it. They've never done any tests. They've never done any experiments. They've never done any measurements. They've never done anything.
Yeah, could be. It's tough.
Maybe the
It's
guy
tough.
in here that he wrote his PhD dissertation on direct and indirect detection of dark matter. He didn't know anything. He's an astrophysicist.
For me, if I go to space and I see it,
Yeah.
That's it, man. It's like there's without a doubt, like doing the calculations here on Earth.
Don't you understand how contradictory you're? How do you know it's actually a ball? I mean, you saw the Earth is flat and you didn't believe it. How come you're going to believe it when you see it as a ball?
Let me finish. I have to make I have to orbit around this fucker.
Okay. I mean, that's fair.
Space is fake, dude. You're gonna find out when you get your vacuum chamber. You're not gonna orbit anything.
Do you think an orbit has ever been actually observed by anybody?
30 people, apparently.
They saw something orbit? From where?
Are those people in the ISS right now? Right.
They only see 3% of the Earth.
What do you mean?
From the ISS's altitude, you would only see 3% of the Earth.
Yeah, it doesn't matter. They're still traveling around the Earth.
How do you know? It's like being in an airplane, dude. It's like being in an airplane.
Yeah. They're just looking out the window, man. They can't tell if they're going around anything. They could be just going in a big circle, which would be the same thing. It's just a difference of the circle. So one circle flips upside down, one just goes left or right, right? So they could just be going in a circle. They can't tell from where they are. See, fundamental problem, I keep bringing up things that you go over have in common, is when you think about the world, you think about it from a third-person point of view and don't think about it from what people actually experience by looking out their eyes. Okay, from the viewpoint of someone on the ISS, they're only going to see 3% of the Earth, and they're going to have no fucking idea they're going in a circle, they're doing a loop-de-loop, or anything. Especially if they're in free fall. They can't feel which way the spaceship's going, right? They have no idea where they're going. And there's no way to tell visually. So
here's my question to you, Saucy.
Yeah.
So if you're waiting to go to space to prove the Earth is a globe, then why aren't you thinking the Earth is flat until proven otherwise?
Because I can't prove that it's not refraction or fucking whatever else they say.
You can't prove that it is refraction.
You can't demonstrate that refraction could even do that in the first place.
So we can just get rid of refraction now, so you don't even have to worry about it. So what's your next one?
Okay, let me ask him this.
Hang on. Why is he giving? I just wanted to know why he's giving the globe the benefit of the doubt observation of reality.
Because consensus means something to me. I know.
Oh, okay. Yeah, no, got it. Right. Thanks, religious.
Slurp. So, listen, what if they said electromagnetism made it look flat and not refraction? What if they just said some other physical law? Wouldn't they have to justify that in some way?
So what would that look like to you for them to show you that it is refraction? What would that look like?
Measurements.
Okay.
Like measurements, but the measurements that have been done show that refraction of that type is not possible. That's the rub. See, this is why I'm asking you very simple questions, right? Because because what they like to do, the people that the Goldbergers that debate this topic, they want to bring up a refraction. So you go down the rabbit hole of nonsense instead of tackling the fundamental premise in the first place. Is refraction even capable of doing what they say, making a curved surface look flat? Is it capable of doing that?
Right.
But also there's a caveat to this. The caveat is, and that has to be the only visual phenomenon that you see, meaning other effects associated with refraction, such as dispersion, vignetting, right? Magnification, shrinking, things looking smaller, things looking larger, things looking distorted. Those
You know
can't
why?
hold on. Those things can't be there.
I know.
Only that
You're
one
right.
thing of a flattened globe. That's
No, like
nonsense.
I said, from my point of view right now, this is definitely the best case for it, right? 100%. I'm just saying, for me to accept this one anomaly, if I can call it that, for a glober, everything else falls apart to me.
What anomaly? Which anomaly are you talking
Okay,
about?
I'm not gonna call it anomaly. I'm not gonna call it an anomaly. I'm just saying, if I were to
don't know
accept that it is,
exactly what you're talking about. I
if
don't
it's
know.
a flat, if it's a flat Earth, then I'm gonna have to like fucking contend with the idea that okay, somewhere around here there might be a fucking edge and water's just flowing into whatever or flowing down.
Why would that happen?
I don't know, because if it's, are you saying that it's an infinite expanse?
Okay,
You don't know that, right?
well, first of all, water. If you thought that there was the edge and water is going off into the vacuum, water evaporates in
You don't
vacuum.
believe it. You don't believe in the
No,
vacuum,
hold on.
remember?
But that's what you're saying. That means water would evaporate as soon as
No,
they hit
I'm
the
not saying.
vacuum.
I'm not saying that. I'm saying that if it's
Well,
flat,
why would you
unless
think
it's
that
an
there's an
infinite
edge with water
expanse.
falling off of it?
Okay, fuck the water. I'm just saying there's
Falling
got to
to
be
where?
an edge. There's got to be an edge, right?
Why?
Okay, so it's infinite to you.
No, that's a false dichotomy, dude. Infinite is the act of counting. So this is a bad idea that people have, that infinite is something, dude. Infinite is the act of counting.
You'll walk in a circle before you find anything relevant.
So
why is
then
that?
you can always count the number afterwards. That's said to be infinite, right? So an infinite set, an infinite series, an infinite enumeration. There's always something that comes after it. Okay?
Yeah, okay, fuck infinity.
Why would we?
You know what I mean. You know what I mean.
Finite. Well, no, this is very important because the choices here are finite or infinite, but those are actually not opposite things. They're used opposite in modern language, but they're actually not opposite things. So we're talking about spatial properties. So anything logically that is an object must be inside a greater space, right? So you have a beach ball is in a swimming pool, right? And the swimming pool's in the yard. And the yard's in the town. And the town's in the country. And the country's on the continent. And the continent's, surrounded by water, inside the water. And then the water's inside the earth, right?
You know what's surrounding
And then
the
the
Earth?
Earth's inside the solar. I'm just doing the globe one. The Earth's inside the solar system, and the solar system's inside the galaxy, and the galaxy's inside the great fucking void, and the great void's inside the universe. What's the universe inside?
Yeah, we haven't observed that. Yeah.
Well, if it was inside, anything that you could say exists, by definition, is inside the universe and can't be outside it, because the universe means everything.
All I'm asking you is, what do you think?
No running away, dude. Don't run away. This was your question.
He already answered the question, Indio. He said we have. When Indio asked you the question, what was outside the universe, you said, "I don't know. We haven't observed it yet."
Yes.
Okay,
that's the answer.
That's the
That's your
answer.
answer. Okay.
That's
Okay.
the answer about flat Earth. There's no evidence that there isn't outside. There is no evidence you can go outside. There's no evidence that there's some freaking limit or wall or boundary or edge or anything like that. There's no evidence of any of that stuff.
Yeah, which says something to me.
Yeah, that the Earth is the universe.
No.
Just because you can imagine you can go outside the Earth doesn't mean you actually can. It doesn't even mean that there is something outside the Earth. Can you go outside of your body?
Wish.
If you wish, probably not. You probably don't wish that wants to happen. But
You don't want to astral project, brother.
well, I mean, that's what the globe Earth is. It's just literally, it's in the word, astral projection.
Dude,
You're
why do you got to
imagining
do
that you've
all
left
this
the
weird
Earth and you're
shit?
looking. Yeah, well, I mean, yeah, it's exactly. It's the globe Earth is just a crazy occult religion, dude. If you want to boil it down.
So you guys always want to float, you want to fly, you want to astral project, you want to go to space. What is wrong with you people?
What's wrong with that?
They want to. The chains of gravity are like slavery, holding us down. Swing low, sweet chariot.
I think
Break
that if
free
you
from
actually,
gravity.
if it was possible to live where there was no gravity and you just like floated around, they think that that would be fun. After about an hour of that, you would want to just be like, put me back down because this is not going to work out for me.
How about when you get like 90 years old and can't control your bladder and like piss is like flying everywhere in little balls?
No, all you have to do is just get seasick and start puking. That's it. It just takes one day, and now you got 9 people puking all at the same time.
Yeah,
Go clean that up with a mop.
Yeah, fucking lo mein floating around everywhere. Gross.
All up in the corners of the air vents and shit, getting sucked in. Gonna make myself throw up thinking about it.
All I'm saying is we don't have evidence of an edge, right?
That's right.
Why would we think there's an edge?
We don't have evidence of outer space making people float. You're going to find out with your vacuum chamber that water doesn't exist in a vacuum. So you can't have a ball Earth full of water floating in a vacuum.
I wondered how the thought would have finished. We don't find an edge, but we still measure the surface as flat. What was you going to say?
I'm just saying that's just another point on the graph. Yeah, I said already that it is pretty sus how we don't see a curve. It is pretty sus.
We don't
but
measure one either.
It's also
The
pretty sus
important
that we
part
can't
is we
find
don't
an edge.
measure one. That's the important part is we don't measure one. Seeing is not dispositive, dude. Seeing is a subjective activity. Now, seeing a no curve is a good starting point, but that doesn't mean it's not proof. It's just evidence. The proof is the measurement. You understand?
The act of I know I know
if I
what you
look
mean.
at railroad tracks and they appear to converge, how do I prove they're parallel? By looking at them. You understand? Seeing is the projection of the 3D world onto a 2D surface. Okay?
Sure.
So seeing has a fundamental flaw. You're missing a dimension. And it's only true from your fucking perspective. But from other perspectives, it's different. That's why we have this orthographic shit. Okay, we have
We're not
blueprint
really
drawings and all those things, right?
Our vision isn't orthographic, but I see your point.
I know.
Our depth perception is flawed and may vary from person to person. I get what you're saying.
No, it just gives us a different. It's not that it's flawed. It's that we can say different things about the world than orthographically. So, but with vision, we can look at something and get the angular size, visual size of something angularly. You can't get that orthographically unless you take a third point that's not part of the orthographic diagram and project part of the orthographic diagram out of it onto a point. Then you can get the angles of, say, the angular size of an object. But
No, I get what you're
it's
saying.
just
Yeah.
different. It's just different information. That's all it is. It's different information. It's not right or wrong. It's just different information. You're not getting the whole thing. You're getting part of it.
I know our vision is flawed. We have to measure it.
It's not flawed.
It is.
It's incomplete. What would perfect vision look like? Where you have like a 3D hologram in your brain of what the world is?
Superman vision.
Probably, yeah. Like, you know how in like video games you can just fucking
No,
you have like a
Video
fucking
games, man.
graph. You have like a I mean
third
yeah,
person.
Turn the video games off, dude.
Are you in a third person shooter or a first person shooter right now?
all I'm saying is if you had
Duke
if you knew
Nukem.
where everything
Yeah,
is
baby.
in XYZ, that would be perfect, right? I'm not even saying that's possible. I'm just saying you asked me what would perfect be. I'm telling you that is perfect. I could know something where it is in space relative to the origin with precise well up to 32 bits or 64 bits. But yeah.
Okay. But you know what? If you had orthographic vision and I gave you a gun, you would never be able to shoot anything. Because you'd have no perspective. You'd have no idea what the angle of the object is out there in 3D space.
Let me think about that. No,
You don't
that
have
would
angle.
be right. That would be right because you would direction is still going to be the same, but you're just not
Direction out
going
of what?
you just can't you just don't have depth perception. That's what orthographic is. You lose the depth perception.
But it terminates at like your gun is a point, right? It has to terminate at that point, the barrel of your gun.
I'm not sure what you're saying.
The sights through the gun.
The sights of the gun, right? That's where the bullet goes.
Sure, I'm saying you're still pointing in that direction. You just don't know how far it is because you're now orthographically projecting, right? You don't have depth perception.
Yeah, but okay. I mean,
You're
this
still
is
going to
a
be
tough
shooting in that direction.
Okay, but if you saw the world in an orthographic view, when you took your little gun and went to shoot for somebody, you'd miss.
Not true. That's literally what I'm saying. You just don't know how far he is.
No, you don't know the direction.
Not true.
Yes, true. Okay, I'll tell you why it's true because
Bro, in my video game right now, I can have raycasts from my camera down to a point on the plane.
Still
even
in
with
perspective.
Yeah, that's great, right? That's
That's
all.
in
That's all
orthographic.
fantastic. So orthographic is like a blueprint.
Have you ever played a video game like back in the day where everything looks like?
Dude, I played Pong. Okay, like don't ask me if I played a video game back in the day. I played Pong when it came out.
Okay, well that's in 2D. It doesn't work.
Are we speaking past each other? Do you know what orthographic is?
All your games are 2D too. They're just drawn like 3D.
You
No, they're
understand?
simulated in 3D. Yeah, that's a fair point. But
Can you give an example of an orthographic projected view? I don't think you what's being said.
No, I do. An orthographic projection is where your camera, the frustum is it's a cube, right? Or it's a rectangle, or not? Yeah, it's a cube. It's not. They're parallel. These the borders. So everything appears to you like it's the same distance, right? It's not. It's what he said. It doesn't go to a point because you need.
That's right.
Yeah.
But you're the point.
But directions are still the same. The direction that you're pointing at is
not
still
from your
gonna be
viewpoint, though.
Yes, it is.
Okay, look, you would have a bunch of parallel lines. You're going to be aligned with one of those parallel lines. That will only be your only, like, you don't have a point of view. There is no such thing as a point of view. That's why it's not perspective. Perspective has a point of view, meaning there's a point which the whole 3D image is projected on, which converges.
Not true. Not true, because you can say.
Where does an orthographic projection converge?
There is no convergence, but you can say I want to shoot a ray. I want to shoot a ray from this XY, right, and then go straight.
Yeah, go straight to where?
Straight to whatever.
What do you see?
Whatever
A
it hits.
square?
Yes, in that. I mean, in that case, you're just gonna hit whatever.
I mean, I think I know what the problem here is. Do you know what what the hell is it called? A telecentric lens is?
No.
Okay, so it's a lens that they use in manufacturing that they'll like when they need to precisely measure the part.
Sure.
Okay, it there's no perspective. It's an orthographic image with a camera lens, and the reason it works is because the camera lens is the size of the part. So it's a 5mm part. You have a 5mm lens, and it's a parallel projection because the lens is big enough. There is no point projection or near point, even near point projection. Like you said, frustrum. Say you had a 10mm part and a 5mm lens, you would have a frustrum with a back plane, front plane, right? Where the front plane would be the camera lens of 5mm, and the back plane would be the part of 10mm. Now you could do a calculation and do some, computer-aided fucking correction, but you can just get the telecentric lens and just make it the size of the part and not do any of that. Now, there's some videos on YouTube where people they make a giant telecentric lens that's like it's about, I don't know, 10-inch diameter lens, and they run a train at it on train tracks, and it doesn't even look like it's coming at the camera, even though it is coming right at the camera, because it doesn't have a direction from the observer's point of view. There's no direction that like goes to the observer. Everything doesn't converge at the observer.
Sure, that's if your constraint is you can only shoot the ray from the middle or somewhere, but that's obviously not what I'm saying. I'm saying you can choose an XY. You can choose an XY on this square and go forward. That's what I'm saying. Yeah, if you're saying you can only shoot from fucking 0, let's say that's the middle of the screen, then yeah, you're never gonna hit. You're only gonna be.
Dude, you can't do any of that on a ball. You can only do all of that in a flat game.
Anyway, this is all like whiskey past the graveyard. We don't live in an orthographic. Well, hold on, dude, just one sec. I'm only gonna say this. We don't live in an orthographic world, though. We live in a world of perspective. That's what we see. When we model the sun, moon, earth, all these objects, right, that we see, right, they're supposed to be objects. The mathematics is an observer-centric perspective, all of it. They don't use a globe. They assume that you're a point at the origin of coordinates in astronomy and all these places. All these models are actually observer-centric models. And the only reason they use a sphere is because it's easier to calculate if they assume that you're just a point at the center of the sphere. Anyway, whoever had something to say, go ahead. Okay, then. Have a nice day. Be sure to tip your waitress. So, Radwin, what was the vacuum test he's going to do?
I'm going to drop two things.
He's going to, no, you first, you're going to, before you ruin your vacuum chamber, first you're going to put a half a shot glass of water in there, and you're going to time how long it's going to be till your vacuum chamber is completely dry. I was going to say it's about an hour is my guess.
How do I, it's like I need a humidity fucking sensor?
No, you'll see, believe me, you'll see it. You'll see it all over the inside of the vacuum chamber. As soon as it hits a certain point, it goes poof and turns into a cloud. Because when there's no pressure, the water turns into gas. So that's why you can't have gas balls in a vacuum and water balls in a vacuum.
Yeah, it evaporates. So basically, it's going to condensate.
Yeah,
right,
so
on the side.
Earth can't be a water ball in a vacuum. That's correct.
It's actually sublimation. The water sublimates out of the air that's dissolved in.
I can hear the gears turning in his head.
So, Sauce, if you pay attention to this topic, what you often see is there's two classes of argumentation. There's descriptions of what's actually happening, like what's actually observed, and then there's explanations. Okay. A lot of times people try to pass off the explanation as the description. For instance, solar eclipse. I saw the moon go in front of the sun. That's the explanation. But that's not an accurate description of what was actually seen, because you can't see the sun during the moon during a solar eclipse because it's a new moon. So they never saw the moon at all. This is something you'll see if you're engaged in this topic over and over again. Colberters they'll say they're empiricists, and you'll ask them for evidence, and you'll ask them for data, you'll ask them for experiments, like the one Rabnin just said, gas balls in a vacuum. And all you'll get is an explanation. You'll just get a story. You'll never get the actual data, the actual experiment to back up any of the claims. This happens repeatedly over and over and over and over and over ad nauseum. But science, as you should know, is based upon empirical, meaning from experience, observation, or experiment. Technically, just pure observation is not science, but let's just put it under the broad term of science. Okay? Observation and experience, period. That's it.
Hold on. So explain to me why if I see like water droplets on the side of my vacuum chamber, why does that disprove gravity or whatever you're saying?
How come it was held down before you put it in there and remove the air pressure? It was held down by gravity then, but when you remove the air pressure, gravity gave up on it. So is it the air pressure holding it down, or is it gravity holding it down? You decide.
I don't see how that follows. Like, because if the water turns into gas, that's what we see even in non like
Yeah, so
in a
gases
non-vacuum.
are not pulled down by gravity, are they?
Okay, so if I had, let's say, if I had
your
like
brain, didn't it?
Yeah, gears turn again.
Not really, but if I had
No
like
gears are turning yet. Okay.
If the water is like blue or something, right? And I can see the gas, let's say, what you're saying the gas is gonna what's gonna happen to the gas? You're saying it's gonna rise?
Let your vacuum chamber run until it's dry. Yeah, you let it run until it's dry. You don't just turn it on for a second and say, "Oh, I pulled a vacuum." You let that thing go for about an hour.
Mm-hmm.
It'll be bone dry. If not, let it go a couple more minutes. It'll dry up.
Yeah, but there isn't an atmosphere around the container or inside of the container, but surrounding the gas. It doesn't follow.
What the hell does that mean, dude?
Is the atmosphere the container?
Are you telling me that the air turns into some kind of solid container that holds water around a ball then?
Are you saying the gas contains the gas? Because the atmosphere is the gas.
Let me search.
I know you're not sure what you're saying. Yeah, so you're trying to just make up anything. It's like you're panicking now.
No, I'm just trying to follow a train of thought and see where that leads me. Let's see, like.
Okay, just go by the second law of thermodynamics. Gases have infinite degrees of freedom and try to reach thermodynamic equilibrium within their environment. If they're inside a vacuum, and there's a barrier, and you open the barrier, the gas will expand to fill the available volume and trying to reach thermodynamic equilibrium. Gravity has no effect on this process and is nowhere in the kinetic theory of gases or any gas laws. There's just no gravity in any of the formulas because it has no effect on gases. You would need to have gravity in the phase diagrams for the transitions of matter from phases. That gravity would create pressure, which would change, and temperature, which means it would be able to do work. It's like this. The gravity thing is like outside all the physics, dude. It's just its own special category of physics that somehow is immune to all the other physical laws we have.
Just remembered we needed the container for the vacuum.
And remember, do that first before you throw your vacuum chamber out your window and prove nothing by doing that, except you can prove that you're going to break shit.
Bro, I'm not gonna drop a bowling ball. I'll drop like maybe a feather or something else.
He thinks he's going to drop them inside his vacuum chamber, and that's going to prove if they fall at the same time somehow.
Okay, but that's not all elements, is it?
Relevant in the sense that there is something making it fall.
No, he said it's not all elements that do that.
Okay,
So
but yeah,
some
I
of these
don't buy into that video.
Well, I mean, you don't buy into the video? What video?
The video that you guys showed, right? The Bremen
drop tower. He saw that and panicked. He saw that elements don't drop at the same rate in a vacuum. Now he's going to go buy a vacuum chamber and drop his vacuum chamber.
Oh, what I saw was one video.
Yeah, they kicked him out.
They wouldn't let him do anymore.
Yeah, what is his name? I want to search him up.
In the video description is a link to his website. He's a German guy.
Well,
there's English translations on the website of everything. He has research papers, all that stuff is on there. He's not the only one that's done this, or something like this. There's another guy who's currently doing it. His name is Sky Darnos. But he's done a different type of setup. So because of air resistance and you have different elements, your elements would have different shapes. What his way around this was to take the elements and stick them inside a basically like a ping pong ball. But it's just a plastic ball with hemispherical cells that snap together. So now you have unified air resistance. The air resistance is the same for every single one. So he takes 1 gram of each element and measures what the rate of free fall is, and it's not the same. It varies by element, and from what he's deduced, that the more neutrons that are in the element, the faster the rate of fall. Now, he has a whole theory behind this, but this is he's a physicist, PhD, all the math, all the crap. He's written 2 books on it. So the equivalence principle was never proven.
Sounds like neutrons are pretty heavy shooting for ground like that.
Like, you can't just have one video and say, "Oh, here."
I just gave you a YouTube channel. He posts his experiments.
But you said that it's not the exact same. Like, we were talking about repeatable.
It is listen. He takes an element, like say a gram of lead, and a gram of iron, and a gram of calcium. Because of their densities are different, they're not going to be identical shapes. So you can't just drop them the way they are as a gram, because they'll have different air resistance. So he solved this by taking them and putting them each in a ball. Now, because they're in the identical kind of ball, they have identical air resistances and identical weights.
This is very dependent on a state of matter. Solid, liquid, gas. Are we dropping gases in
He
vacuums?
controlled all the variables except for the element is what he varied, the element that's inside. Weight is the same, geometric form is the same, air resistance is the same. So everything's the same.
Somehow that okay. All right, let me think about this. You have a container that is the same.
Yes,
and it contains whatever it contains, whether
contains
liquid,
an element that weighs 1
yeah,
gram.
right. It doesn't matter if it's solid or whatever because you have this outer shell anyways.
Yes. And he drops it and he times how fast it takes to fall.
Okay, where is this video?
It's a bunch of videos, so I'll post a link in the side chat to his channel. Tons of videos. He also got talks that he's given at conferences, and you can watch them if you want.
Okay, so it shouldn't be too hard to find that.
His theory is that inertia and gravity are not the same, right? So you had the equivalence principle where inertial mass and gravitational mass are identical. He's saying that that's not true. That the so-called gravitational mass is based upon the number of neutrons inside of an element. Technically, not the number of neutrons. It's a little more sophisticated than that. But the neutron count is the easiest way to tell what it is. But it's an interaction between the neutrons and the protons. It's not specifically their binding energy, but it's like that.
Is it the neutron count or isn't it the proton count? I'm not gonna get too technical.
According to him,
I think
it's the neutron count.
All right, let's see this shit.
Well, I mean, there's a lot of experiments in there. Good luck. But I can give you interviews that he's given explaining the principle and his experiments.
Which one's the video? The latest one?
There's a bunch of videos of him doing, dude, they're experiments.
I know, but you're citing him, so I trust you to give me the best one.
Every single, look, I'm citing him. You can watch them at your leisure. I describe them. Okay? My only point is that the equivalence principle has never been demonstrated experimentally. Remember I was just saying that we're going to keep busting up against explanations versus actual descriptions of reality? The experiment is the description of reality. You do an experiment, you measure the metrics or whatever it is you're observing, and you just describe what's happening. That's it. But then there's the explanation of why it happened or how it happened, the story we tell to make it sound better, or whatever reason we do it. Here, let me find a drop test for you.
Forgive me for asking, but what conclusion are we trying to get to or reach?
I don't even know. If you click the videos tab, it's like him just freaking doing experiment after experiment after experiment, man. And some interviews, apparently. Rubber zinc free fall comparison. Lead zinc trials using the same vending machine ball. Rubber zinc trials. I mean,
Yeah, I'll look at them. But I'm going to look at
free
this.
fall experiments, lead versus steel.
Hey,
0.3
what's this
millisecond time
experiment going to do for you, dude? What's it going to do for you when you find out that things fall at different rates? What is that going to mean then?
It ain't gonna prove a globe, and it ain't gonna disprove a globe. It isn't gonna do anything. It might be an intellectual curiosity.
I just
mean,
wanted him to tell me what this actually means.
If they don't fall at the same rate, that means everything. That means gravity is false.
What?
Ugh.
It means that it can't be a globe.
No,
it means you can't pull a perfect vacuum.
It wouldn't mean it can't be a globe.
It does.
In your mind, maybe, but really, no. Things going up and down, really? You think that that's going to prove a globe?
No, I need to see like vastly different rates, right? If we're talking about if it falls
0.3 milliseconds in like 6 feet.
It's 0.3 milliseconds, the difference?
Yeah, I'll post that one in the chat. I just read it to you.
Wait, let me see. 0.3 milliseconds.
Here, I'll post in the chat on. He's not dropping this for stories either. But this, you still didn't tell us how this would, like, I can't even believe I have to defend the freaking globe. This would.
I don't think 0.3 milliseconds is so tiny.
What?
The difference.
Okay,
it would
get on your computer and give yourself
create
0.3 give yourself 0.3 milliseconds lag. You tell me,
bro.
You'll be in here fucking crying, dude.
What are you talking about?
I'm laughing.
We play video games at 30 milliseconds, brother. At 50.
Dude, I played at 900 milliseconds.
No, you didn't.
Over.
How long is a millisecond, Sauce?
A millisecond is a thousandth of a second.
Okay. So when we used to be on dial-up, yes, I used to play at 900 milliseconds. Thank you very much.
Brother, I'm telling you, that's impossible.
They wrote way better netcode back then than they do now. Now they write trash.
900 milliseconds? That's almost a second difference.
I know that.
You'd be shooting at shadows, my guy. You'd be shooting at ghosts.
You have to have great anticipation. I could pick people out of the air with the fucking rocket launcher, bro.
0.3 milliseconds? That's the fastest fucking internet connection I've ever seen.
Well, I mean, no.
If you had 0.3 milliseconds,
if you're on fiber, you can get down. You can get like less than 1 millisecond.
Yeah, if the fucking server is right next to you.
But listen, it's not a far drop, and that's a huge. If they dropped it from 1,000 feet, it would be like a fucking second difference. So it doesn't matter anyway because it wouldn't prove or disprove the existence of Earth being a ball or not. It doesn't have.
It would mean that it falls within the parameters, the margin of error, because we cannot create.
What's the margin of error? How did they figure out what the margin of error is?
Whatever it is, it's good enough for me because this is such.
How do you know? Well, how do you know? Since you don't know what it is, how do you know that it's good enough for you?
Oh God!
All I'm saying is it's not an open and shut case because literally. We cannot create a perfect vacuum. And
do you know that if you listen to yourself right now, you're just trying to talk fast and say anything at this point?
No, I'm saying that we cannot create a perfect vacuum, as that gives me like some sort of out, right?
So what are you going to prove? Yeah, what are you going to prove by buying a vacuum chamber then?
You need a container for gas.
I still want to see it for myself,
What? You said you can't create a perfect vacuum, so what are you going to witness?
It would be cool to see fucking feathers fall like without any air resistance.
Feathers fall. No, there's air in there. Remember? Plus, feathers are heavier than nothing. So,
Radman, should we really ruin this freaking day of space travel?
yeah, he needs it done. You go ahead.
You know what happens? Like, you know what it takes to create an ultra high vacuum on Earth?
No.
You need double vacuum chambers. And every time you turn the vacuum on and raise it to that high vacuum and you open the door again, you need to change the seal. A metal seal. They can't use rubber seals. They have to use metal seals because when they close the door, they bolt it shut and the metal is soft and it deforms and what do they call it? Cold welds to the other metal, right? So it's basically molecularly sealed at the molecular level. So when they open the door, they got to scrape that shit off, put a new seal on. How do they open and close the door on the ISS, which is a vacuum which is like 10 to the 11 torr, and the highest Earth vacuum is 10 to the -7 or something? Why aren't they changing these seals? And where is the giant frickin' copper seal that's like 3 feet in diameter that they have in the ISS that they have to replace every time?
And I want to know where they keep all the spares, and where do they keep all the spares all clean and safe?
Do they have them in those little fucking surgical fucking paper things that they keep Band-Aids
No,
in?
they must have it in their MRO room, like up against one of the fences, is all my guess. Hanging.
Well, they can't keep it outside because there's like seaweed and barnacles out there.
Hold on. So you're asking what? How do they get out of it? ISS, right?
No, we're asking how do you open and close the door more than once on there?
Okay, let me see.
How do you just open the door and never close it again?
Hold on, Indio. He's going to ask AI.
Oh God. I know what the AI is going to say. NASA is really good at engineering seals.
Well, it's NASA. What do you think? I mean, does he know that NASA is a spy agency now?
Oh shit! Did you tell him?
No. I thought somebody else would have told him by now. You know that, dude. NASA is now a spy agency, right?
Officially
on paper.
Yeah, that's what.
What?
Do you think we're joking? No, there's an executive order. You can go read it on whitehouse.gov.
So now when you say you believe what NASA says, that means you believe in what the KGB tells you, basically.
Remember Airplane when he the Russian dude is reading the freaking news? There's like a gun off the screen, like pointed at his head. You see like an arm certain up the side of the screen, force him to read whatever on the news.
Yeah.
Could you repeat your assertion? What was the problem?
Changing the seals.
Changing the seals.
Yeah, when you change the seals on a vacuum chamber, so you have a reverse vacuum chamber. The vacuum's on the outside, the air's on the inside, as opposed to the air on the outside and vacuum on the inside. So it's just the reverse of the problem. You have the same problem. So ultra high vacuum we know from manufacturing what it takes to create one and what it takes to use one in industrial enterprise. So we know that if you want to open it up, you need to replace the seal every single time it's opened.
Why?
Because when you close it, there's a metal seal. It's metal, like copper. And when you close it, it deforms. Okay? And cold welds to one side and deforms on the other side. When you open it up, you can't get it to redeform the same way. It's a one use only. You can't use rubber because the rubber outgasses and decays in vacuum. So it has to use, and it also don't make as good a seal. So have to use metal.
So what they're saying is there's actually
I can show you a
not that
video
much.
from a vacuum manufacturer. I mean,
They're saying there's not
in my
much
opinion.
pressure on the ISS. They're saying there's not as much pressure on the door. It's only about 1 atmosphere, which is basically like on Earth. So
Well, yeah, but if it's 1 atmosphere on Earth, why don't they just use the same seal that they use on the ISS on Earth to make their vacuum chamber?
It's the same pressure values. It's the same problem.
No, it's in space, so it's way different, dude. Don't you know that?
Are you not saying that? Are you not saying that because the pressure is so high that the material gets deformed? Is that not what you're saying?
No,
it gets deformed when they close the door.
Yeah.
The steel does. But when you reopen the door, now that steel is no good and you need to replace it.
But what? But
where are the replacement seals? You would need 3-foot diameter replacement seals because the fucking hole is 3 feet in diameter.
But
wouldn't this also apply to the doors on the Apollo landers?
Yes. It would apply to any fucking thing that's in vacuum that you have a door that you have to shut and open. And there's cold welding problems. In a vacuum, when you touch two metals together, they'll cold weld together and you'll never get them apart again. This is a known phenomenon, man. This isn't like new shit, man.
Okay, what is this phenomenon called?
Cold welding.
Cold welding. All right, thank you. You're saying this happens on the ISS? Yes or no?
No, it should happen on the ISS, but the ISS is fake, so no, it doesn't happen on the ISS.
Okay, so it should. Okay, listen.
You've got, in both situations, you've got a door that separates 1 atmospheric pressure from an ultra-high vacuum. Whether it's on Earth or up in the sky, inside or outside, the door is still separating the two things, the ultra-high vacuum from the 1 standard atmospheric pressure.
Now, I hear you.
Cool. Talking a lot about containers, but you figure out that door problem.
No, I know what you're saying. You're basically, he was saying that you put a vacuum chamber in a vacuum, or I mean, you put whatever in a vacuum chamber, and it should, yeah. You put a shuttle in a vacuum chamber, it should cold weld, or that's what you're saying. We observe here on Earth, right?
I'm saying when they touch metals,
yeah,
together,
should
when you're
cold
doing
weld.
on a little spacewalk, or when the ships touch each other, they should cold weld together. Okay, there's a video of ultra high vacuum, and what they say, you can listen to the lady. This is a ultra high vacuum manufacturer saying what needs to be done. They're one-time use, the seals. You open the little hatch, you can never use it again. That means you got to have seals on hand to replace every time you open the door. Open the door, go outside. Oh shit, we need to replace the seal right now before we can even shut the fucking door.
Will this happen in my vacuum, or must this be like a super vacuum?
No, that's like ultra high vacuum. That's like 10 to the -5, 10 to the -6 toward in that vicinity. But the ISS is something like 10 to the 11 or something. 10 to the 9.
So like in between then.
We can't even make the vacuum of where that thing operates. We can't make that vacuum on Earth.
Hold on, you said 10 to the what for an ultra vacuum?
10 to the 9 or 10 to the 11, somewhere in there.
But the ISS in outer space, you're saying it's
10
like
to the
more.
9. That's the 10 to the 9, 10 to the 11 tour. Okay. On Earth, the largest vacuum we can pull a 10 to the -9 for a very brief period of time for like making microprocessors, but it's for a very brief period of time on the order of fucking like 2 or 3 minutes. But the typical ultra high vacuum that can be maintained is like 10 to the -6.
Deep space is supposed to be.
Look, there's this thing called outgassing. So when you manufacture things on Earth, right, there's gases, right? We got the air and air pressure. Say we make a piece of metal and we forge it. Inside that metal are dissolved gases. When you pull a vacuum with that thing inside it, those dissolved gases, they come out of the metal and they cause what's called spillation. And you'll have a bunch of fucking holes in it. Well, that ain't no good if you want something structurally sound in outer space so you don't fly apart from the ultra high vacuum. So you have to pre-treat all this stuff before you can even expose it to vacuum. But how do you pre-treat it before you even get it into the vacuum? There's a big question. How did I pre-treat the entire ISS in an ultra high vacuum at high or in a vacuum at high heat to get rid of all the dissolved gases, and then stopping that process and then going to space? Did I fucking saran wrap it? Did I put them in big Ziploc bags? Like, did I vacuum seal? Like, what did I do? How did you even do this?
Oh, that's a massive problem for all space travel. You start talking about moon buggies with rubber on the moon. You want to talk about Tesla and his car, his showpiece of throwing his Tesla's car into space. The amount of outgassing that all of these things would take place. Yeah, good point, India.
Yeah, the fucking Tesla would have exploded, dude. You would have just saw fucking seat foam flying everywhere. It wouldn't even be seat foam anymore. It would just be freaking a raggy piece of freaking polyurethane. So, Sauce, foam is dissolved bubbles inside of like polyurethane or polyvinyl or PVC even. Right? It's just it's bubbles that are dissolved in there, but they're dissolved in there at 15 pounds of pressure per square inch. Each bubble, each little teeny microscopic bubble is in there at 15 pounds of pressure per square inch. Thousands and thousands and thousands of them. You fly your Tesla into space. Now that fucking seat with the polyurethane foam, all those bubbles want to expand into the available fucking vacuum. The fucking goddamn seats would have exploded. Never mind the plastic fucking, because also the plastic has dissolved gases. All this stuff has dissolved gases in it, and they would all explode. In ultra high vacuum, the vacuum they say it is.
Yeah, but that's assuming you're not protected from the vacuum.
Well, I mean, the Tesla that Musk says he launched into space was not protected from the vacuum.
He just rolled it out of the parking lot. That's what
said they didn't do anything to it.
Yeah, that was the claim, wasn't it? Didn't do anything, just took a warehouse and chucked it into space.
You have to look at this foam you're talking about then.
Foam? You've never seen foam, like for a seat?
Well, I have to search up the material. You said poly something?
It could be polyurethane foam. Like, just open like closed cell foam, man.
I mean, look, we got to get specific, right?
You never seen like polyester foam?
I don't know the fucking Tesla.
You own a pillow. Do you have a rock for a pillow or something?
If you want to get specific, just understand that what outgassing is. We can be specific about that. And then we're just going to have to look at all of the things that are apparently said to be thrown into the vacuum of space. Now, a little bit of discernment will help you understand that things like rubber, foam aren't going to do very well in vacuums just because of the phenomenon of outgassing. They're not going to be very good for, well, let's put it like this. If your life depends on it, now fuck up. So back to the door.
I just posted an image, dude. This is foam for upholstery. That's what's in a car seat.
Yeah, you're saying that in a vacuum, it's all just gonna expand outwards, right?
That foam is just bubbles.
Yeah.
Okay, Source.
If you take
do
one
it
of
the
these and
easy-
stick them in a vacuum chamber, they'll freaking expand. Same way as a marshmallow. You can actually probably look at that on YouTube, right? Put marshmallow in a
Yep.
vacuum chamber.
I'm gonna search up this Tesla video.
Not the one that's real because it looks so fake.
What's up, Matrix? Sorry to cut you off like that.
Well, actually, you said exactly what I was going to say. Go and stick a marshmallow in a vacuum chamber.
Yeah. Dude, I want to try that, though. I bet you I'd eat the fucking marshmallow.
It's a shame they don't stay big. Put them in the vacuum chamber, expand them out.
Right, they shrink. Lame.
Freaking mint, wouldn't it?
Well, I guess you can be like that astronaut, like be in the vacuum chamber with the marshmallow and try to eat it before you pass out.
Best of
And
luck.
be like, my tongue, the water was boiling up his tongue. Is that what he said? He could feel
in
his
that
tongue
article.
sizzling or something, he said.
Yeah, in the article where they stuck him, the actonaut in the vacuum chamber, they claimed that he could feel it before he passed out. It was one of the last sensations he could feel was the moisture coming off of his tongue.